Hello, everyone. So glad you are joining us today for the third session of our What's New in Solid Edge ST8 series, Assembly Design. My name is Diana Dietrich. I'm the marketing specialist here at Swish Technologies, and I will be your moderator for this session. Just a little bit about Swish. We've been a leading provider and partner of Siemens PLM software for over 10 years, headquartered in St. Louis, Missouri. Our team is dedicated in providing you the best training, support, and software, including NX, Team Center, and Solid Edge, necessary to accelerate productivity in your processes. Also, we pride ourselves in delivering process-based training solutions tailored to fit your company's needs. With our educational training services, our goal is to make you a leader in your field while staying ahead of the competition. Joining us today is application engineer Dale Duell. Just a little on Dale. Dale is a certified Solid Edge professional and trainer. He has supported, trained, and demonstrated Solid Edge to more than 1,500 students across America and is the author to several custom Solid Edge manuals that are used globally. Our agenda for the day is on assembly design, where Dale will cover topics in the subject matter including mass properties, match checkpoint, top-level file open, and missing file repair tool. Following a brief history of the topic, Dale will be providing a demonstration within Solid Edge ST8. We will then end with Q&A, so if you have any questions whatsoever, please don't hesitate to add these into the questions box located on your GoToWebinar control panel. Dale will have your questions answered during the Q&A portion of our presentation today. All right, take it away, Dale.
All right. Thanks a lot, guys. All right, so let's go get started. Welcome, and thanks, Diane. A couple things we're going to talk about today, as Diane had said, is mass properties, variable table motor, match checkpoint, range relationships, top-level file open, and missing file repair tool. There's a lot more that's going on. Just an inside note, all of the application engineers at Swish, we spend a week down in Huntsville where this is where the Solid Edge is developed. We spend a week down in Huntsville every April or May, right at the end there, and there's just too much to try to even go over. So what we try to do is just condense it down, and but literally there is a wealth of information that we can share with you at any given time. So let's go ahead and start looking at the Solid Edge and ST8 and what's new in ST8. So the first thing I want to talk about is the idea of missing file repair tool, and we're going to actually learn two things at once here. So missing file repair tool, and I want to show you this by looking at our thing. Well, we'll go do small icons. There we go. That'll just help a bit. So I want to open this, but I wanted to introduce a new thing before we get to the missing file repair, and that is the top-level assembly documents, the top-level assembly documents. And I want to show you this, the practicality of that. So let's take any one of these files. There could be, 100, 200 files in this folder. But as I look at this, say like this screw, and I know this is used, or maybe this stem. This stem is used in the assembly, and I recognize that. But in this list of parts here and pieces in my folder, I don't know what is that top level. I don't know where to start, where's the top, and start drilling down. So Solid Edge and ST8 has the ability now of, once I pick one part or one subassembly, I can just simply come up to the top level assembly filter, and it will filter automatically and find the top level. Now, this works as long as everything is in that same folder. Some stuff may be moved around, but it also works with subassemblies, though. So if I come to a subassembly, say like the spindle subassembly, and once I pick it and I say, find the top level of this, it takes me right up to the top level. So if all of your folders are in one file, and hit any part of that assembly you want, or I'm sorry, all your files are in one folder. Why did I say that backwards? All your files are in one folder, and if you hit one of those files, you say top level, it's going to find that, or if you go to, say, like where all of your assemblies are and you hit subassembly, but where is the top of that chain, it's going to go to those top levels. Now, what has happened here is very frequent inside of the Solid Edge when we come over here. When you open a file, it's not, especially if you have different or multiple users, that you'll see a part that's missing. And we all used to get this, cannot load these files, cannot find them. And that would be kind of the end. You'd have to go out, repair them, or edit a link. Well, that is until the Repair Missing Files tool was included, and this is included in ST8. So it allows me to take that part and to actually scroll out to that part. See, previously it was hidden in under here, and if I take that part and just click on it, it's going to scroll out and tell me where it's missing. So not the assembly is missing it, but a subassembly is missing that part. So it actually is going to scroll out, open to that subassembly, and show me where that part is. Well, here's some other things I can do with that then, is I can replace the missing part with a new part. So in this scenario, we may want to take a part or take an assembly, move everything over, and just get rid of something, right? And then as it comes back in that assembly, it says, oh, where's that base? I don't, where's the motor? I don't, where's the spindle? And then you just say, I'm going to replace you with a different spindle or a different motor. So I can replace with a new part. I can also replace with a standard part. So if someone makes, say, like a homemade washer or a homemade pulley or something like that, I can actually go out and say, I'm going to replace that with, more of a standardized feature. We can also just simply replace a part. While that part isn't there, we just go right-click and say, okay, yeah, the heavy duty isn't in there, so I want the light duty, or the right one isn't in there, so I'll put the left one in, or something like that. You can replace that. What I'm going to do today, though, is search and replace. So I'm going to go browse, and I'm going to get as close as I can to my where I think it might be. So we'll look over here, and I think I'll take what's new in assembly, and I'll just add that to the path. Now, I can add multiple paths, so I can say search in this folder, then search in this folder, or then search in that folder, and then of course I can move up and down, right? I can say no, search in this folder first. So I can search in a folder, and I'm just going to hit search and replace, and Solid Edge just that quickly is going to go out and replace that missing part with the correct part that where I told it to look for. So there's two things we're talking about so far. We've got about 5 or 6 things to talk about today. One is the top level assembly, and then number 2 is this find or replace missing part. It's going to go out there and allow you to find those parts and replace them, or or find them, replace them, or make another part from that. So very very user-friendly, very good set of tools here. So let's move on just as quick as we can, and we'll talk about mass properties. And then any time that you feel like it, again, ask questions, jot the questions down. We'll try to answer them at the end. But at any time that you have questions, feel free to ask a question. So here I'm going to look at the mass properties. And there's been an update to my mass property. Okay, so we're going to go look at this for a second. Now, I'd like to kind of teach 2 things at once. I'd like you to get, what's new and what's old at the same time, if you will. I want you to get, once you get an idea of how everything blends in. Again, just my little soapbox here, Solid Edge is not a collection of functions, right? It's not one hole, one circle, a square, a draft, a drawing, an assembly. It's this whole thing, is that I can make parts, put them together, and then draft them out, test them. I can order them. I can send it off in a document. I can send it out in a 3D PDF if I want to. So we're not talking about piece parts here. We're talking about whole benefit of what the program is going to give us. So the same way with here. Here I just want to show you that I've drafted this at some point. I'm not sure where I drafted it. I'm not sure where I put it. So I'll just come down to my manage and expand my manage, and I'll just go down to my where used. So I'm going to go to my where used, and I know this part has been drafted, but I don't know where, right? Where did we put it? And I don't want to have to open and this, that, and the what I want to do is start to work on this part, but I know I'm going to open that draft sooner or later. So I'm going to do my where used, and here's a little hint. When we start to do a where used, it's the top address here, where it's going to start looking for, is always where this part came out of. So it's always going to start with its home folder, if you will, its home address. So we'll just simply do that. I could add addresses and add folders and things like that, but I know it's going to be used there. So I'm just going to say next, and it's going to go out and find itself. It's going to go find that assembly. Well, from that assembly down, it's going to go find its own draft. If I expand it just a little bit more, it's going to say there's nowhere else where used. Okay? It's not gone down any further. So I can take this draft, which is what I really wanted in the first place, and just say open. And just open that draft, and we'll just update our views. Okay? So I'll open that draft. Now, we've got this assembly. It's been drafted, and it's got a bill of materials, and I want you to see this shipped assembly weight. So here's our bill of materials, and we've added everything, all of our piece parts down here, and then I've added quarts of oil. So this is what we call a non-graphical bit of information. In other words, it doesn't have a picture. Doesn't have a picture associated with it. It's right down here. You won't see the part highlight. In fact, you just see the ordinance there. We just drug it in there, and you won't see that. But it needs to be in that assembly nonetheless. So let's take this quarts of oil here, and I'll right-click and go to my occurrence properties. Now, if you're new to occurrence properties, what this is something that's been around for many, many years. It's the ability to say, do I want this part to be seen at a higher level? Do I want it to roll up in my bill of materials? Do I want it to be seen in the draft? So we got some sort of super secret project, and then when I draft it, all I'm doing is drafting everything around it that's holding it, that's holding the black box, if you will. Okay, so I can choose to do what I want to with these occurrence properties. This occurrence property of the quart of oil, I'm just going to say user-defined quantity. Okay, and back here is to say, do you want to define the quantity of this? No, I'm going to let Solid Edge do that. I put 1 in, the bill of materials shows 1. If I click on the space and say yes, and then it'll say, how many did you want to put in there? So let's say 5 quarts. It's like my car. We're going to put 5 quarts of oil. So we're going to go put 5 quarts of oil in there, and then as I come back to my mass properties, that's the whole theme of this one, as I come back to my mass properties, it's going to give me 2 different weights. 37.9, roughly 38 pounds, is how much this assembly is going to weigh with 1 quart of oil in it. The 1 quart is the 1 quart that we put over here on the left-hand side. 45 and some odd pounds is how much it weighs now because I went to the occurrence properties and put 5 quarts in it, right? I overrode that. So in ST8, we get the option now to use as the assembly mass. So here's the mass when we overrode the quantity. If ever you're in doubt, just read the sentence backwards. Here's the mass when we overrode the quantity. It's now 45 pounds. Do you want to use that as the overall mass. If I say yes, and I say update, then that 45 right there, we'll save this again. Move a few things here. We'll save this again, and I'll close this out. And then it will be reflected not only in the weight, but in the bill of materials as well. Okay? So that update mass, that's something that we couldn't do prior to it. We could override the quantity, but the mass, you could put 100 screws in, and it wouldn't be 100 screws heavier. It'd still be the same amount. So what we can do now is override that, put, say, like 100 screws in, and then, or 5 quarts of oil, and then actually have the weight reflect what's going on there. So this is our new mass override mass property that we have, and we can override when we use the occurrence properties. All right, now next thing is let's open up match checkpoint. I think you're going to like this. I know I do. So let's go look at this real quick. Match checkpoint. And as I come down to my solid edge options and I look in my assembly options, I want to show you a new line that's in one of these check boxes. And it says match click points on the parts when creating first assembly relationships pre-ST8 behavior. What it's saying is, do you want this solid edge to assemble like it did in version 7? So if you're in version 7 or 6 or 5 or 4 or all the way down, you're pretty much used to what I'm about ready to do. But then I'm going to show you what ST8, what Solid Edge 8 is going to do on that. So I'm right now, the way it's shipped unchecked. So it's going to act like version 8. I'm going to check it and on purpose make it act like version 7. Let's say you like it the way it does that, okay? So I'm going to make it act like version 7 and before. So here we go. And I want to show you what happens with this is I'm going to assemble, and I'm going to take this ring and I'm going to set it right down there, right, to be coincidence. Well, do you see how it falls inside of there? And we always do that, and then we always have to go, oh, let me get that back out. Okay, oh, now let me go finish, the assemble, and now we go, like that face to that face, right? And then we keep it from rotating if we like. But we have to do something like that. Or we've learned over the years to mate first and then axial align so the part doesn't disappear. Well, that's been improved, upgraded, in any other way you'd like to say it. So here's what's going to happen now. I'm going to assemble, and before I assemble, I'm going to go out to my options, and I'm just going to uncheck this. Now, if you never knew about it, and if you never knew you could check it one way or the other, it wouldn't matter. It would just do better. All right, you would just know, you'd notice the improvement. But I'm just showing you how you can check and uncheck it. So this check match click points on the part when creating first assembly relationships pre-ST8, the same thing I checked in my options, well, that options is exposed out here, and I'm going to uncheck it. I'm going to say OK. So what does that do for me now is as I assemble that ring to there, you notice how it just sets right in line. Okay, so it just sets right in line. It doesn't bury itself. It doesn't follow my cursor. It just simply moves across, and then I can set it there and be ready. Okay, so that's match click points. And the click points was from here to here, and in version 7, all the versions that you have, that's what it's already been doing. In version 8, it will not do that unless you check that and want it to do that. On version 8, it will actually just move over and then be ready to set down. I think you'll like that. I like that a lot. All right. So let's look at another new new ability that Solid Edge has, and that is to override the range. I'll tell you what, do I want to do that? I think we'll save that one. I'm going to skip up. We'll skip up to something else. Diana, if I should forget this range relationship, let me know, would you? And you kick me over the phone here and let me know. So I want to talk about the animate adjustable assembly. And I want to look at a nice function that we have, and it's called a variable table motor. And so if you think about this, the motors that we have, and I'm going to go do a little bit of work to set this up, and you'll see me do it live, but we have a rotational motor, go 120 degrees in 3 seconds or something like that. We have a linear motor, go out 5 inches and come back and stuff like that. But we also have a variable table motor now, and that means I can actually take any variable that I want, and you'll see it in a second. Let's say something's 100 millimeter, and all I simply do is just say, in this 3 seconds, change 100 millimeter to 50 millimeter or 70 millimeter, and we'll change that right off the bat. So let's start working with just a few things, and we'll kind of go back into ST7 and kind of get a running start here while we're at it. So I got a couple plates, the shaft and that type of stuff, and I want to put some springs in it, and I want to put some things I have to adjust. So as I look at this, my first thing I would naturally want to do is I would want to pattern this piece into this plate. And I would want to do that, but if you know anything about this command, right now it says it's, start, pick on the pattern. Oh, there's no pattern in this piece, all right? So there's no pattern. I can't put that around. So we're going to back up and talk about a little bit what we did a couple weeks ago about pattern recognition. So I'm just going to open this part, and what I'm going to do is window over what I call the master occurrence, okay, or the first part. This is the main occurrence of my pattern. If there were a pattern, I would want it to start here. That's what we're saying. And then I will just simply come over and say recognize pattern. It's going to go find that pattern. There's one straight up from it and 2 straight across. So it understands that this is a rectangular pattern. I'm just going to say OK. At this point, I'll close, come back to my assembly. So this plate here could have been in IGES, it could have been in step, it could have been from anything. It could have been 3 or 4 holes put in at different times by different people. But now it's my pattern. So as I have this, I would just simply take my assembly pattern, and I'll say take piece, yes, and put it in this piece, this pattern, and it's going to go in all 4 of those holes just like that, where we couldn't have had that before. Now, the next thing I want to do is go grab my part. We'll come up here. ST8 assembly, yep, here we go. We'll find our part. And I'll just take my adjustable spring, and I'm going to bring my adjustable spring in, and it's going to remind me that it is adjustable. And it's going to say, would you like to place me as adjustable, or would you, place me rigid? In other words, flexible or as designed, right? And I'm going to say place adjustable. Be flexible about this. And I'm going to bring that in, and then it's going to ask me what variable do I want it to work on, and I want it to work with this 100 millimeter. That's the distance between the 2 plates. At this point, I don't know if you guys ever do this, guys and gals ever do this, but hey, don't be afraid, while I bring this in, I want to see that sketch. Why? Because I want to axial align that sketch to that shaft. And you see how that match click point, you see how that's working in our favor now? And then I'm simply going to drag the component, and I'm going to set this with detect collisions, and I'm just going to bring it down this way, and as soon as it hits the bottom plate, it's going to stop. Can't go any further. okay? So we'll just leave it like that. Well, now I've got to get all 4 of those into that spring in all 4 of those posts. Yes, I can pattern, but there's something that in version 7 that I think you're going to like, and I don't know if a lot of people are using it yet, but here's version 7. I'm going to go and duplicate the component. And what I'm going to say just very simply is this component is going to be duplicated every time it sees a post in this assembly. And just like that, it's going to go match all of those all the way around. Okay, so wherever that post is, that post gets a spring. Doesn't matter if it's upside down, if it's on the outside edge, if it's going around in a figure 8 pattern, it doesn't matter. Wherever that post is, that's where the spring goes. That's called duplicate component. And it allows me just to attach, basically, figure this as one set, and then everywhere this goes, it just finishes out the set. Okay? So we'll have something like that. I'll go turn this back on. And I'm going to go out to my tools and look at my tools. I'm going to my express route. And it's just kind of a general thing while I have your attention. It's not really new. It's just general good stuff to know while I have your attention. And I've created a path here. And I'm just going to run a tube. And I'll give it a part number and an outside diameter. I don't want it to be 5 millimeter. I want it to be 15 millimeter. And I'm going to say OK, and then I'm going to pick that path. And Solid Edge is going to put that path. Now that tube, its only process, or its only purpose in life there is to go from one port to the other and follow the center lines of that path. How long is it? It's as long as it takes to go from one port to the other and follow that path. We actually don't care. We can actually make a rigid tool, a rigid tube if we like, and make it not change length, but I'd rather let it be flexible and let it move with us. Okay, so we're just going to say OK and get back out to our assembly. All right, so now we have our springs setting out there, our plates, and now I'm going to make a variable table motor. And I'm simply going to say that I want to pick that 100 millimeter, I'll pull this out of the way, and I want it to come down maybe 10 centimeters a second there, and I want it to come down 30 millimeters. I want it to come down, so it's going to go negative. If I go positive, it goes up. It's not impressive if you do it that way. You want to make sure it goes down. So I will say OK, and then I'll simulate that motor, just like we would anything else. Take that motor and simulate it, and I'll start it from the beginning, and I'll just play, and all of those springs will just naturally go down. The hose will go down and everything else. So this is a variable table motor, and we're going to look into this just a little bit more in the next two or three topics here. But this is a variable table motor. All it does is say, take this variable and control this variable. Change it from 50 to 60 in 10 seconds. Change it from 90 degrees to 60 degrees in whatever in 2 seconds, whatever. But that's a variable table motor. Looking forward to using that a lot in the future. So let's go back up and look at this one more time, actually three more times actually. And this can be done, this is an assembly sketch, but this can be done in 2D. You want that assembly sketch going on here. Now, before I get too far along in this, I'm going to create a part in place just to show you what's going on, and I'm going to call it part 1. Okay? And I'm going to do this in ordered. I'm just going to right-click and just say I want this in ordered, because what I want it to do is follow the sketch. Synchronous is not tied to the sketch, which is a lot of benefits. ordered. It can be tied to the sketch, which has its benefits as well. So I want to look at this. I'm going to go make an extrusion off of this plane, and I'm going to steal or include that whole frame right there. And then just bring this out. This is some sort of block, knife, comb, pusher, anything that you want. Okay? And I'm just going to save that and run back up to the assembly. Okay? So this sketch is being driven by a motor, and this sketch right here is already laid out. And it's not complicated. It looks like it is. It's just saying, you know, I need definite lengths, I need some radiuses, some tangencies, and I'm working on this 50 degree. Okay, that's probably what's most important. When I look at the motor, the variable table motor, it's just going to pop right up, and it's going to show me that that's the thing it's controlling, and I can edit that just like anything else, right? I can edit that, but I'm having that go around, and now I'll simulate that motor. I'll say variable table, that's the one I want. And if you look down at the bottom of my screen, I can choose what I want to update. And this is new in ST8 as well. So I can choose what I want to update. So let me lay out the story real quick. If I have a really large assembly or a really large machine, and I can lay this thing out in 2D. I can just say it turns, it pushes, the drill comes down, you know, it gets pushed over on the side, it gets stacked. You know, I can even do that in 2D and then make the parts go with that. But I can lay that completely out in 2D. No one's against using 2D inside of Solid Edge. So you can do that the way you like. So I'm going to have my motor just to update the active assembly. And that's just the constraints within this assembly. And we'll just run this, and it will run that part, okay, or run that sketch. You've seen that sketch is just going with the 50, and it's going down to 360 or coming back around, whatever constraint that we have set for it, it's going to obey that. If I go let this start again and go to that bottom left-hand side of my screen, and I go to activate or active level, that means this level of the assembly and all the way down, everything in here. So think about that. I can take 2D and make this process go through, a machinery process, or I can actually have the sketch physically drive everything. So think of all the time that we're going to save by not doing rotational motors and linear motors and things like that, but using that variable table motor. Just say, everything that's connected here, you go back here and you start running. So I've got this now at my active level. I'll run back and I'll hit play. It's going to run just a little bit slower, but it's actually going to run that part. So you think about that. I mean, doors opening, lanes shifting on the conveyor side. Which way do you want? Drills coming up and down and that type of thing. You can actually drive it with a 2D sketch. This is very, very cool. Now, I want to open one more, open our last one, and we'll look at our range relationships. You thought I was going to forget it, didn't you? Well, back in Solid Edge version 6, ST6, we added range relationships, and what that allowed us to do is to basically drag a component within a range. So if I click on here, this cylinder here has a range of 1 to 250 millimeter. Do it any way you like, 1/4 inch to 10 inch. So that's where it runs back and forth. It's very, very simple at this point just to drag this component, and we'll just do no analysis, and drag this component. It was very simple, but you notice that it has a definite start and stop point. That's within that range. Okay, so that came out a couple years ago, and we used that quite a bit. But the problem was to try to add any other constraint to it. So it had a range to come, back and forth. But if I went and said, no, okay, I really can worry about the angle, then we'd have a problem because the program thought it was already constrained because it had a range. Didn't realize that range was still flexible. So in ST8, that's been relaxed, so we can actually do this, and we'll just simply say, I'd like to put an angle between here and out on this face, and we'll just say okay and have an angle relationship. As we look at that, the angle relationship is 286 degrees. You can have it any way you like, but that angle is 286 degrees. So to that, I want to add that variable table motor. And I'm just going to go out and look at the variable table, find out that 286, that's the one that I want, and I'm going to say, 30 degrees, and the limit is 60 degrees, and I want it to go to the positive. And I'm going to say, okay, and that's it. And then I will just simply run that variable table motor and add, and just hit play, and I'll watch it run. It's just that simple. See, it's done that quick. Back and hit play, it's going to go out. So even though there's a range relationship here, that this can come out 1 millimeter to 250 millimeters, even though there's a range relationship here, I can add an angle relationship between the two blades here, and then I can add a variable table motor that allows that part to run the way it should. Alrighty, that's what I have for now. Is there any questions? I'll stay in the solid edge in case there's any questions.
We actually do have a couple of questions, Dale. So the first one in our queue is, how do you stop creation of backup files, solid edge assembly configuration file in assembly folder?
Okay, a couple things. How do you can stop a backup file by going to your solid edge options. Let's just get out of the animation. It's kind of a two-part question that you asked. I think it's actually a very good question. So let me go to my my solid edge options. I'm going to go to save. Now here's where your backup file is, your .baks, okay? And that's where those are. And those backup files, you notice mine are not done. If I check on that, preserve prompt, create a uniquely named backup copy every 5 minutes, okay? Needed, not needed, that's up to you. That's why the check mark is here. I don't normally do that. I'll tell you one thing I really don't do is prompt me to save my documents. I don't want to do that. You can do it if you like. If that's company policy, go ahead. I don't like to do that because it'll prompt me to save, and I'll go yes, and I'll go, oh shoot, no, I didn't want to save it, right? So I just get into the habit of, Control S. Every time I like what I see, I just hit Control S. So those are your backup documents. Now, the configuration file that you talked about is a slightly different issue. What that is that if you think of it as the top table of contents of that assembly. So we're looking at what colors, it's everything about this. This happens to be brass, this happens to be stainless steel or whatever, or copper, or chrome rather. I know the difference. But as you look at that, that configuration file is in there automatically. And that's, what position is everything in, what colors are they, what particular ingredients, individual piece parts that are in my assembly. That's what holds everything. I'd like for them not to be seen, but you're going to see them, I guess. The point of it is whenever you just make one, it makes it, if you move that assembly somewhere else. That configuration file follows it. Gee, it'd be great if we could just say, stop showing me these things. But those are necessary, but they're the, if you will, they're the bill of materials, the table of contents for that assembly. And that's what Solid Edge relies upon. On a side note, just real quickly, if you have the same assembly, the exact same assembly, and your partner has the exact same assembly, and his or hers looks better or is working better than yours or something like that, you can actually keep two different assemblies and take that configuration file and bring it over and replace it, and then yours will look like theirs. That's a little deep, but it can be done. Okay. Excuse me. Hopefully I answered that one. Probably answered it. It's probably as clear as mud now, but anyway. Any other questions?
We have time for one more question. So it is, can you suppress certain posts as needed? Seems like it will be just checking. And he was referring to the duplicate part pattern where you added the springs to each post.
Yes. You can pick individual one. The button that I picked says, let's go pick them all. And you can have that choice. Some people like to pick 100 and get rid of 5, right? So they wanted 95, but it's easier to pick 100, and they deselect the 5. Other people like to pick 95 until they get 95 of them. So you can hand pick the ones that you want, or you can say pick them all. Boom, they go everywhere, and then it's a pattern, and it's in the Pathfinder. All you have to do is just open that instance up and say, no, delete that occurrence, and then that file will go, that particular post and spring, whatever, or that particular post will not get a spring, and it might get something else. But yeah, you can let the system pick them all, and then go back and delete some of those occurrences after it's done it, or you can individually just pick. But that button there at the end is to actually pick all of them in that occurrence. They're great questions.
Great, thank you so much, Dale. So unfortunately, we are out of time for the afternoon. However, we want to be sure that if you do have any questions about today's topic, you have the right contacts to go to. So if you have any questions relating to utilizing the program tool, please feel free to reach out to Dale by phone or by email. He's more than happy to help. Or please reach out to your Swish sales representative for further information. If you don't have a Swish sales representative, please feel free to reach out to me, Diana, and I will direct you to our sales manager here at Swish Technologies. Once again, thank you so much for attending Assembly Design. We hope you can join us for our 4th installment in our series, Weldment Design. It's next Wednesday, October 7th at 2 p.m. Central Time. If you haven't registered yet, please be sure to do so in the email invitation that was sent out, or by going to the official series page, which you can see on the bottom right there.